Hello, pre-calculus. Today we'll be going over the fundamental trig identities. And this will correlate with Chapter 7 material, so make sure you are doing the homework in MyLabs Plus. Alright, so let's take a look at this. First thing we need to discuss is even and odd function. And before we discuss them in terms of trig functions, let's explore them in terms of just regular old exponential functions so we can better understand where the terms even and odd come from. Alright, so an even function means that if you plug in a negative, any negative number, you will get what that function would have been ordinarily if you had just plugged in a positive number. Now for an odd function, if you plug in a any negative number, then you will get the negative value of if you just plugged in the x function normal. So let's do a couple examples of each with the exponentials. And so let's define f of x for the first one as x squared. And so if you plug in a negative x, well then you get negative x quantity squared, which of course is x squared, and x squared is the function itself. So for any negative number you plug into the function, you get what it would have been ordinarily. Alright, and let's look at another example. Let's go for f of x equals 5x to the 10th power. And so if you plug in an f of negative x, then you will have 5 times negative x to the 10th power. And since it's an even function, or even exponent here, it's going to make it positive. And that is our function. So we kind of get a better understanding of why these functions are called even. It's because if the exponent is even, well, you have this relationship right there, and so we call it an even function. Let's just do one last example here. We'll set f of x equal to x to the 4th plus 2x squared. And so when we plug in our negative x, we get negative x to the 4th plus 2 times negative x squared. Right, so this negative x to the 4th, well, that simply becomes positive x to the 4th plus 2 times positive x squared, which again is our original function. Alright, that handles even. Let's take a look at odd. And note for the odd function, you plug in any negative number, then you get that negative output out there. So let's look at a few examples. Let's look at the identity function, f of x equals x. You plug in negative x, and what do you get? You get negative x, and that is the negative of the function. And if you plug in, or if we use, let's say, f of x equals x to the 7th, plug in f of negative x, that's negative x to the 7th, and you'll get a negative x times x to the negative x to the 7th, which is simply the negative of the original function. So there we are. Remember order of operations. You evaluate this first on this one, and then you apply the negative. Over here, first you take x and multiply it by negative, and then you apply the exponent. So note that in this case, whether you do it one way or the other, they are in fact equal to each other in that very specific case. Now all functions are either even or they're odd, or they can be neither. They don't have to be even or odd. But very special things happen when the function is either even or odd. Alright, so let's take a look here. This is our x-axis, and right here this is our y-axis. And note as drawn, this guy right here is where we measure our angles from. So let's go up an angle of theta. And remember, our cosine and sine values correlate with our x and y values on the unit circle. And so this is cosine theta and sine theta. Right, x naught is cosine theta, and then y naught is sine theta. And note that the x value, if you come straight down, well, there's our x naught value. And if we run straight across, well, there's our y naught value. And again, x naught is cosine, y naught is sine. Now let's go down in the other direction. We're going to go the same magnitude, but in the other direction. So this is the result of basically plugging a negative theta into the cosine and sine, which puts us right there. And so we have x naught and y naught. Actually, let's call these x1 and y1 to differentiate. And so note that as far as the x value is concerned, x1 is the same thing as x naught. We'll leave that blank for the time being, which is the same as our original cosine theta. And again, what does x1 equal? x1 equals the cosine of negative theta. So we're saying cosine negative theta is the same as cosine theta. Now let's look at the y value. There's our y1. But note that the distance from here is the same as the distance from here. The only difference is that this distance is positive and this distance is negative. So we note that y1 is the same thing as negative y naught. And so that negative y naught, well, that's the same thing as negative sine theta. And so our y1, that was again sine of negative theta. So both these things right here imply that cosine negative theta is the same thing as positive cosine theta, and sine of negative theta is the same thing as negative sine theta. And this will be true for any theta that on the unit circle. So this implies that cosine theta is even and sine theta is negative. So let's go ahead and write that down because that's a nice result to have. Cosine theta is even and sine theta is odd. Okay, there we go. All right, and let's go ahead and see what this implies for the other trig functions. Let's think about tan theta. Well, we're going, negative theta because we want to see if it's even or odd. Well, what is tan theta? That's sine over cosine. And as we already saw from right here, sine theta is an odd function, so we have negative sine theta on top. Cosine theta is an even function, so we have a positive cosine theta in the bottom. So sine over cosine with a negative sign up front gives us negative tan theta. Tan theta is odd. Okay, now let's look at some of the others. Cotangent of negative theta. Well, now that's simply cosine of negative theta over sine theta. And for the same reasons of tan theta, we're going to end up with a negative out front because of this guy down here. And so it simply becomes cosine theta, negative cosine theta over sine theta, which is again going to be negative cotangent theta. So both tan and cotangent are odd functions. All right, let's take a look at secant theta, or the secant function, secant negative theta in this case. Secant theta is 1 over cosine negative theta. Cosine is an even function, so it becomes 1 over cosine theta, which is the same as secant theta. So therefore, secant theta is even. All right, now the last one, cosecant. Well, that's 1 over sine negative theta. Sine is an odd function, so this becomes 1 over negative sine theta, which is simply negative cosecant theta. So the cosecant theta is an odd function. All right, so there are our results. All right. So that handles even and odd for now. Let's go ahead and remind ourselves of the following. If you have a theta, angle theta right here, and then we have our x right here. What is our x value there? And then we'll call this our y value. And if this is a unit circle situation, which it is, the hypotenuse will always be 1. All right, so again, this would be, a hypotenuse of 1. This would fit nicely on the unit circle. So let's first go through everything. Pythagoras says x squared plus y squared equals 1. And now let's calculate cosine theta. Well, that equals the adjacent, which is x, over the hypotenuse, which is 1, so it's just x. And then let's look at sine theta. Well, that's y divided by 1, which is just y. And so we can plug both of these values into the Pythagorean theorem. And so when we do that, we get cosine squared theta plus sine squared theta, and that equals 1. This is a fundamental trig identity. This is very important. Now from this, we can figure out some of the other fundamental identities. This is called the Pythagorean identity. And again, it is very important. You should commit that one to memory if you do not have it already done so. All right, so let's use this to come up with our other Pythagorean identities. First, we're going to divide that initial guy by cosine squared. And when we do that, the first term becomes 1. Second term, sine squared divided by cosine squared. Well, that's simply tangent squared theta. And then on the right-hand side there, 1 divided by cosine squared is simply secant squared theta. And there is our other Pythagorean identity. Now again, we can now divide this by sine squared of theta. When you do that, cosine squared divided by sine squared is cotangent squared theta. Then, of course, sine squared divided by sine squared is 1. And then 1 divided by sine squared is simply cosecant squared theta. And there is our other Pythagorean identity. All right, so these three are very fundamental. Make sure you are familiar with them. Note that the key to understanding all of this is to simply go back to the triangle here, the right triangle, as applied to the unit circle. All right. So let's go ahead and look at a few things. If tan theta equals 5, what is negative tan theta? Well, as we saw before, tan theta is an odd function. So if tan theta equals 5, then tan of negative theta simply equals negative 5. Now let's take a look at tan theta equals 5. And these would be specific thetas, not theta in general. So maybe for all of these we should add just a little naught so to remind ourselves that we're talking about a specific theta or have a specific angle in mind. All right, so first off, tan theta not equals 5. Well, we have this guy here that we can use. Oops, did not mean to erase that. There we go. So we say, well, we got 1 plus tan theta squared. So we've got, that's 5 squared. And that equals secant squared theta. All right, so you can kind of see how that works. All right, and so we just go through. 1 plus 5 squared is going to be 26. And that equals secant squared theta. And so what does secant equal? We take the square root of both sides. And so secant theta equals positive or negative square root of 26. Okay, so that gives us a good idea on that one. Let's go on to the next. We're down here now. Use cosine theta equals 5/8 to find the following: sine theta, tan theta, and secant of negative theta. All right. So here we simply go cosine squared theta plus sine squared theta equals 1. We're going to plug our value in right there. So we have 5/8 squared and plus sine squared right here. Alright, so now all we have to do is solve for sine theta. And so we get sine squared theta equals 1 minus 5/8. Which will mean that we have 3/8 right here. And we have to take the square root of both sides. So what does sine theta equal? Well, sine theta could equal positive or negative square root of 3/8. All right. And so you can see here we use the fundamental Pythagorean identity. Let's look at tan theta. Now you can use the Pythagorean identity using tans, but we don't have to do that, because what does tan theta equal but sine theta over cosine theta? So we just plug everything in. This is simply going to be cosine theta in the bottom, that's 5/8, and then up top we have positive or negative square root of 3/8. And there are a number of different ways we could rewrite this expression here, this number. And so we'll simply write it as positive and negative 8/5 times the square root of 3/8. And let's convert this into an exponential form. Positive or negative 8/5 times 3 to the 1/2 power over 8 to the 1/2 power. And so note that we've got, a 1 exponent here. 1 minus 1/2 is going to make us have 8 to the 1/2 power. Again, that's just from taking this 1 and subtracting 1/2 from it. So we have 8 to the 1/2 times 3 to the 1/2, and this is all divided by 5. And so we can also write this answer as the square root of 8 times 3 all over 5, and of course 8 times 3 is 24. So we have 24/5, and don't forget to write the positive or negative in for each one of those. All right, so I think that is the simplest expression, and so we'll call it right there. All right, so now we have secant theta, or secant negative theta, should I say. And what is secant theta but 1 over cosine theta? And so 1 over cosine of negative theta is simply 1 over regular cosine theta, since cosine theta is an even function. And so now we simply replace the cosine theta with 5/8. So we have 1 divided by 5/8, which of course becomes 8 divided by 5. There we go, that's our answer. Okay, on to the back side of the handout. We're going to express tan theta in terms of cosine theta. So first off, we start off with what we know. Tan theta equals sine theta over cosine theta. And again, we have tan theta now expressed as sine and cosine, but we only want it expressed in terms of sine, right? That's what we want. And so what we need to do is get sine in terms of cosine. Well, we already know from the Pythagorean identity. We have cosine theta here. All right, so now we express sine theta in terms of cosine theta using the Pythagorean identity. And so this, let's go ahead and come off to the side here so you guys can see it. Cosine squared theta plus sine squared theta equals 1. So you solve it for sine theta, and you will end up with sine theta equals positive or negative square root of 1 minus cosine squared theta. And so you put this in here, positive or negative square root of 1 minus cosine squared theta. And if you look at if you try and match the graph of this guy and Desmos, which I encourage you to try and do, you will note that whether or not you use the positive or the negative will depend on what part you are on the unit circle. Alright, so let's go ahead and take a look at the next one. Cosine theta equals this guy here. And we want to find sine theta as a function of x. So again, we go back to the Pythagorean identity. Cosine squared plus sine squared is 1. And so what is cosine theta? Well, that's this guy right there. And so we plug that in. We have x over x plus 1 squared plus sine squared theta equals 1. Solve this for sine theta, and we will have first sine squared theta equals 1 minus x squared over x plus 1 quantity squared. Let's go ahead and we're going to go ahead and clean this up. We'll do it in a second because right after we take the square root of both sides equals positive or negative 1 minus x squared over x plus 1 quantity squared. Alright, so now let's go ahead and clean it up. And so here we have x plus 1 minus x squared over x plus 1 quantity squared. So, note that over here, we were just getting a common denominator. And so we'll clean this up. Like so here. And this is all over x plus 1 quantity squared. And so you can kind of see where this is going. This x squared cancels with this x squared. So we have 2x plus 1 on the top. We can apply the square root to the bottom to get rid of that square root. And so we're simply left with positive or negative square root of 2x plus 1 all divided by x plus 1. And that would be our final answer. Alright, so now you kind of are getting the feel for how we can use the Pythagorean identity. And now it looks like we're on the last one here. We have cosecant theta in terms of cosine theta. So first, let's get cosecant in terms of sine. And so sine, as we've already seen, is positive or negative square root of 1 minus cosine squared theta. And let's get this to where we have the radical out of the denominator. So we can do that by multiplying top and bottom by this quantity here, and when you do that we get 1 minus cosine squared theta in the top, and then the whole quantity right there. And there we go, that's it, that's our final answer. Okay, if you have any questions, email me. Otherwise, have a good day and make sure you're staying on top of the homework.